Okay, let's take a look at the graph y equals 1 over x plus 1. So again, we're going to look back at 9.1, graphing 1 over x. We have an interesting looking graph that we talked about. We want to memorize that graph. So if I want to draw this graph, well, we know that, first of all, we have a denominator of x, so we find our vertical asymptote by setting the denominator equal to 0 and putting our vertical dotted line on the y-axis. Remembering the domain is just x can't equal 0. Now, we're taking the old graph and we're moving it up 1. So that 1 is a vertical translation up 1. So we have the old point on the graph here from this graph, this point right here. And we're simply going to move it up 1. Then we have this point right here, and we're simply going to move it up 1. Now, we took a look at horizontal asymptotes in the last question, where if the exponent of x is bigger on the bottom, so we have 1 over x, and we learned that that means that the exponent of x is higher on the bottom, therefore, it would be y equals 0. But we have shifted the graph up 1. So it's no longer 1, it's y equals, no longer 0, it's y equals 1 is the horizontal asymptote. So on the old graph where the horizontal asymptote used to be on the x-axis, now the horizontal asymptote has been shifted up 1 to be on the line y equals 1. Then we can simply draw the graph. So we have close to the vertical asymptote through the point, close to the horizontal asymptote. Close to the vertical asymptote through the point, close to the horizontal asymptote. So not only do we have that horizontal asymptote at y equals 1, that also means that the range is just y can't equal 1. So after we've found the horizontal asymptote and vertical asymptotes and graphed, we want to find the x-intercepts. So x and y-intercepts. So x and y-intercepts. So I'm going to start by writing down the equation. And what do I know about x-intercept? Well, I know that y is equal to 0. So I can put 0 in for y. Then I can subtract 1 from both sides. Then I can times those sides by x. And I know that negative x is equal to 1. And if I divide both sides by -1, I get x equals -1 with my x-intercept at -1, 0. And we already knew that because that was already on the graph from our transformations. Let me circle that one, very important. So then also, we have our y-intercept. I'm going to write down the equation. And then for y-intercepts, we know that x is equal to 0. So I can simply put 0 in for x. Now, can we divide by 0? No. What does that tell us about our y-intercept? None. And as you can see from the graph, we don't have a y-intercept. So a little bit more on the equation y equals 1 over x plus 1. So we have this equation in this form, but sometimes we want to add and subtract fractions. So I need a lowest common denominator of x. Therefore, I need to times the top and the bottom of this equation by x. So I get y equals 1 over x plus x over x. And if I clean that up, I get y equals 1 plus x all over x. So remembering the equation y equals 1 over x plus 1 and the equation y equals 1 plus x all over x is the same graph. So now let's graph that one. So if I draw the graph there, now again I have a denominator, so my VA is simply that can't equal 0. And I can put my vertical asymptote on the y-axis there. Then I don't have a number off to the right, but I do know that I am x to the 1 over x to the 1. And from horizontal asymptotes in 9.1, we have the same exponent of x on the top and the bottom. Therefore, we're going to take the coefficients. And the horizontal asymptote is equal to y equals the coefficients, or y equals 1. So I can put the horizontal asymptote in there. Notice that is the same horizontal asymptote on our old graph. So whether or not we're graphing it in this form or this form, it doesn't matter. So now I know that I've memorized my graph of y equals 1 over x. So I can simply put in all of my points. 1, 2, close to the vertical asymptote, through the point, close to the horizontal asymptote, close to the vertical asymptote, through the point, close to the horizontal asymptote. The graph in the notes looks much better. So now let's find the x and the y-intercept in this form. So x int y equals 1 plus x over x. What do we know about y-intercepts? Excuse me, x-intercepts. We know y is equal to 0, so we can put 0 in for y. Then we can times those sides by the denominator, and x times 0 is just 0. And then we can subtract 1 from both sides, so x equals -1. Therefore, our x-intercept is -1, 0. Notice that's the same point that we got from transformations, and still the same x-intercept as we had before. So now, if we find the y-intercept, we can write down the equation. And the y-intercept, what do we know about y-intercepts? Well, x is 0, so we can put 0 in for x. Now we can't divide by 0, so what we're looking for does not exist. And again, you can see that from the graph. So one more point on these functions. Y equals 1 over x plus 1. Well, we just learned that we can add and subtract fractions and get to the equation y equals 1 plus x all over x, seen by adding and subtracting fractions with a lowest common denominator. So adding fractions to get this way. But how do we go back this way? Well, we have to do long division. So bottom goes into top. And we learned polynomial long division in chapter 3. So we can do long division. So x goes into, I'm going to rearrange the order. So it's in the form x plus 1, because 1 plus x is the same. So x goes into x 1 time. 1 times x is x. And then x minus x is equal to 0. And then we can bring the 1 down, and that is the remainder. And then we can write it in the form 1 plus x all over x is equal to the answer 1 plus the remainder 1 over the original divisor x. So we can clearly see that this function and this function are equal to each other, as we already knew from adding fractions, and now we can go in the other direction for long division. So, reviewing, we may see it in this form, and we can graph it in that form with our instructions. We may see it in this form, and we can graph it, this form, and we can graph it with our instructions. So we can see both of these different forms, and we have to be able to either add and subtract fractions or do log division, depending on the type of graph that you like. And outside of that, if you're ever stuck, we can always graph with a table of values. Never forget that, because so many times we forget all the different methods, and all we ever have to do is choose x values and figure out what the y value is.